Yes, dear students, good evening. Welcome to another beautiful presentation on matrices. In our previous presentation, I have given one simple example that these are the three equations. Okay, 2x minus y plus z is equal to 4, x plus y plus z is equal to 1, x minus 3y minus 3z is equal to 2. So these are the three equations for which you are asking that solve the given equations using matrix inverse method. Matrix inverse method. By using the matrix inverse method, we have to solve these equations. So nothing but by using this method, matrix inverse method, we have to solve. So means that what again by using this matrix inverse method, we have to find out the values of x comma y comma z as we have obtained using our Cramer's rule. Let us recall our Cramer's rule. There what we did actually in that method also, there are three equations given and we have applied the Cramer's rule to find out the values of x, y and z. Okay. Similarly, in the same manner, what we did in that Cramer's rule, but the procedure is not the same in this inverse method. The procedure is something different in this matrix inverse method, but the goal is same, that we have to find out the values of x, y and then z. Right. Quickly, very quickly, I will explain you that how these three equations can be solved. So by using three equations, first of all, as I already given you the hint in the previous examination, directly I am going to the solution part of this question. Right. So first of all, from the given equations, we have to arrange the matrix. We have to arrange the matrix. So from the given equations, right, from the given equations, right, from the given equations, so the matrix A can be obtained. The matrix, right, the matrix A can be written as, you can write like this, nothing wrong in that, can be written as. So what, as I already told you that in the last presentation, A is nothing but A is the matrix which will be formed by taking the coefficients of x, y, z, okay, in these three given equations. Let us consider the first equation. If you see the coefficients, they are like this. 2 is the coefficient of x and minus 1 is the coefficient of y and plus 1 is the coefficient of z. And similarly, from the second equation, the coefficient of x is 1 and the coefficient of y is also 1 and the coefficient of z is also 1. From the third equation, the coefficient of x is 1 and for y it is something minus 3 and then it is minus 2. These are the coefficients of x, y, z from the first equation. These are the coefficient of x, coefficient of y, coefficient of z from the second equation, and these are the coefficients of x, y, z from the third equation. This is the A actually. So and then you have to write like this. So x, this is x comma y comma z, you can write like this. This is equal to, and corresponding constant value. From the first equation, compare these matrices with your equations. If you take the first equation, what is the constant they have given? It is 4. From the second equation, it is 1, and from the third equation, it is 2. 4, 1, 2 is the constant. Clear? Understanding? So this is the A, this is the matrix A, this is the x, some variable, x, y, z are the variables, and 4, 1, 2 is called as the constant, right? So this entire matrix A, I am calling it as something A, and this entire x, y, z, I am calling it as some x, unknown, is it not? This is equal to, I am calling this constant matrix as B. Clear? That is A into x. So this is multiplied by x, no? This entire a is I am multiplying with this particular a into b. I am calling it as a into x. So this means that, you know, a into x is equal to b. That is the relation from here. A into x is equal to b, right? A into x is equal to b. So let us keep this aside, and first of all, for this particular matrix A, first of all, we have to find out the inverse. We have to find out the inverse of this particular matrix A. For this given matrix A, we have to find out the inverse. How the inverse can be obtained? How the inverse can be obtained? Okay, so before solving that inverse, just I will give you a simple brief information about. Very simple. There is nothing difficult to understand. It's very easy actually, right? So as I explained here, a into x is equal to b. Any doubt in this? Any doubt in this? A is the 3 by 3 matrix which I already arranged from the by considering the coefficient of that 3 equations. It is a 3 by 3 matrix. X is the another matrix which is having the unknown values of x, y, z, whereas B is the constant matrix. So I am writing a equation like this: A into x is equal to B. Any doubt in this? And this is equal to x is equal to what is this? B by A. Can I write like this? So I am finding the value of x in a such a way that you take this a value to the right side. That is nothing but b by a, and this can be written as b into, you take this a to the numerator side. This is in denominator, no? You can write this a to the numerator part, then take a here, b into a, and what is the power of a? It is 1. Actually, if nothing is there, 1 is the power of 1. If you take to the numerator part, then it becomes -1. Therefore, x is equal to what? A inverse into b. Shall I write like that? X is equal to A inverse into B. B into A inverse, or otherwise equal you can write A inverse into B. Nothing wrong in that. A inverse into B. Okay, x is equal to A inverse into B. Therefore, I can write like this. X is equal to what now? So, x is equal to A inverse into B. This is the very, very important relationship that I am going to use now to find out the values of x, y, z by using this inverse matrix method. So x is equal to A inverse into B. This is the formula which I need to apply for finding the values of x, y, z. Right? A inverse into B. What is A inverse here? What is this A inverse? A inverse is the inverse of the matrix where A inverse is the inverse of the, what is that? The inverse of the matrix 3 by 3 matrix. That is the inverse of the 3 by 3 matrix, right? Inverse of the 3 by 3 matrix. Therefore, I have to find out the inverse first. I have to find out the values of A inverse, right? Following inverse. How to find out A inverse? That is very important. How to find out A inverse? Very, very simple. Very simple. The inverse A inverse is nothing but A inverse is obtained by using the formula. What is that? By using the formula. What is the formula? A inverse is equal to adjoint of A. What is that? Adjoint of A. A is nothing but our actual matrix only, 3 by 3 matrix. A is the 3 by 3 matrix. For that, we have to find out adjoint of A by the determinant of A. What is that? The determinant of A. This is the formula, friends. A inverse is equal to, what is the formula? To find out the inverse, A inverse is equal to adjoint A by determinant of A. Right? You know what is the determinant of A? That is very easy to find out. Okay? Let us find out that. And after that, we have to find out the adjoint of A. What is the adjoint of A? So I will explain you. First we find out the determinant of A, then find out adjoint of A, then use those two values in this formula, adjoint A by determinant of A, then you will get A inverse, right? First find out the what is the determinant of A. What is the determinant of A? So for the what is the determinant? What is the determinant? So for finding the determinant, first you have to take the matrix. You have to take the matrix. What is the A? A is equal to, I am writing the matrix here. What is the matrix here? It is 2 minus 1 and then 1, right? And it is 1 1, it is 1. What is the third one? It is 1 and then minus 3. Am I correct? And then minus 2. Am I correct? Am I correct? Is equal to, this is what A actually. For this, the determinant can be obtained. What is the determinant? The determinant can be the determinant of A can be given as find out that determinant of A can be written as det A. That is det A, you can write like this, determinant of A. So the determinant of A can be written as like this. Determinant of A is equal to, consider the first element 2 into, ignore that first row and first column, take the sub matrix here, 1 1 minus 3 2, having the elements 1 1 minus 3 minus 2. Ignore the first row and first column, then consider the sub matrix. For that we have to find out the determinant. That means that 1 1 minus 3 2, for this take in this way, 1 into minus 2, right, minus 3 into 1, I am writing, I can write directly because you already know. Therefore, because it takes a lot of steps, if you write all the simple things, I can write directly. So 2 consider the 2. Okay, then take the 1 into minus 2. How much? Minus 2. And minus will come according to the formula, minus 3 into 1, minus 3. That is by considering the first element 2. Then take the second element. For the second element, use minus symbol according to the formula. Minus of minus 1, it is definitely plus 1. Because as per the formula, minus sign will come. Minus into the second element is minus 1. So minus multiplied by minus, it is 1. Therefore 1 into, ignore that row as well as the column associated with it minus 1. Therefore remove these two. Then the elements are, sub elements are 1 1 1 2, minus 2. They take in this way. Then multiply these two. 1 into minus 2. How much? It is minus 2. Then minus 1 into 1, like this, 1 into 1 1. Am I clear? Then for the third element plus 1, take 1 here and then remove that row and then column. Then what are the elements? 1 1 1 minus 3. Then take in this way, 1 into minus 3, it is minus 3 minus 1. Am I clear or not? Minus 1. Then substitute. The second step will be like this. What is the second step? What will be the second step? It is 2 into, okay, minus 2, minus into minus, plus 3, correct? Then plus 1 into minus 2 minus 1, how much? It is minus 3. Then plus 1 into minus 3 minus 1, minus 4. Then I can write here, because due to the space I will write here, don't worry. So then what is my determinant of A? So determinant of A can be written as det A. Determinant of A is equal to something like this. It is 2 into 3 minus 2, how much? It is 1. Then minus 3 into 1, minus 3, plus it is totally minus 3. Clear? Minus 4 into 1, it is minus 4. Then is equal to 2 into 1, 2, minus 3, minus 4. Clear? 2 minus 3, how much? It is minus 1, minus 1, minus 4, minus 5. So your determinant of A is minus 5. Here one important point I would like to explain you is that, remember very very carefully, listen carefully. So your determinant is minus 5 here, the determinant value is minus 5. Remember that. Okay, the determinant, most of the time the determinant of a should not be 0. So that should not be 0, that should not equal to 0. Remember that. Once if it is 0, once if the determinant of a is 0, then that given matrix will not have any inverse. Okay, that is the simple fundamental thing to remember. If the determinant a is equal to 0, the given matrix will not, it will not have inverse. It does not have the inverse. Therefore, the condition is that the determinant of a should not be 0. It is not equal to 0. It can be either positive value, can also be the negative value like this, but should not be 0. Okay, if it is 0, then simply say that if the determinant of a is 0, then not required to solve the question further, for especially for finding the inverse, because it does not have the inverse. Understood? Understood. Then, so this is the determinant value. Now, coming to the adjoint of a. How the adjoint of a can be obtained? Very, very simple. That is another very simple topic, very simple step. So, determinant adjoint of a. How to find out adjoint of a? How to find out the adjoint of a? Very simple. For finding the adjoint of a, what we have to do, you write. First, note down the matrix. First, you write the matrix. Consider the matrix A. Write the matrix. What are the elements actually? What are the matrix? It is 2 minus 1, 1. 2 minus 1, 1. Again it is 1, 1, 1. And the third is 1. And it is minus 3, minus 2. Am I clear? Am I clear? That is the matrix A. Now, for finding the adjoint of A, we have to find out the cofactors. What are the cofactors? Very, very important. We have to find out the cofactors of each element. Each element, we have to find out the cofactors of each element. The element 2, minus 1, 1, all these are, there are 9 elements now. For all these 9 elements, first element, second, third, fourth, fifth, sixth, seventh, eighth, ninth, for all these nine elements, we have to find out the cofactors. And with respect to these cofactors, we have to arrange all these cofactors in a matrix form. Then we have to take the transpose of the cofactor matrix, then that gives the adjoint A. Understood? Therefore, we have to find out the cofactors. Okay, cofactors. Therefore, first of all, what is the cofactor of element 2? So, very simple. Cofactor, listen carefully. Cofactor of 2. So, cofactor of element 2 is can be obtained like this. So, the formula is minus 1 whole power. This is the formula, minus 1 whole power. It is the element in the first row, first column. Therefore, it is 1 plus 1. You can write. Actually, the formula is like this. Minus 1 power I plus j. That is the formula. What is the I? I is the row. I indicates the row, whereas the j indicates the column. So, I is nothing but the first row, j is the first column. This particular element is nothing but the first element of the first row, at the same time first element of the first column. Therefore both are 1 1 only. Therefore I can write 1 plus 1. Now take the square symbol, this square symbol. Then ignore that row and column associating with the number 2. Then if you ignore these two, then what is the submatrix? What is the submatrix? For that we have to write the determinant. So again here 1 1 minus 3 minus 2 are the elements, no? Then take the determinant of this particular 4 elements. What is the determinant? 1 into minus 2, it is minus 2. Then the minus symbol according to the formula minus will come. Minus 3 into 1, it is minus 3. Am I correct? Am I correct? Understood? Are you getting or not? Very, very simple. I am not doing any difficult thing here. So the formula I am substituting simply in the formula. My formula says that minus 1 whole power first element, and so the position of that particular element in the row and then column. What is the position? The position is number 1, first position. So first position in the first row, first position in the first column. Therefore 1 plus 1, first position indicates first position in row, first position in the column. That is the meaning of it. Therefore remove that row and column, then take the sub elements. For that find out the determinant. That will be like this. Then is equal to minus 1 plus 1, how much? It is square, 1 square. Then minus 2, minus into minus plus 3. Am I correct? This is equal to further minus 1 square. If minus 1 square, how much? Minus 1 into minus 1. Minus 1 square, how much? It is plus 1. Therefore, plus 1 into 3 minus 2. It is 1. Therefore, 1 into 1, 1. Therefore, what is the cofactor of 2? It is 1. Understood? The cofactor of element 2 is 1. 2 is 1. We have to remember that the cofactor of element 1 is 2 is 1. Okay, the cofactor is 1. And similarly, find out the cofactor of minus 1. Similarly, so in the same factor, so if I write the second one, you can easily understood. Okay, now the cofactor of the element minus 1, the cofactor of minus 1. Now similarly, cofactor of minus 1 is equal to, now tell me, it is the formula is minus 1 whole power. Tell me the first row, nothing but the first. What is the column? Second column. Therefore it is 2 you have to write. Understood? So first row, second column. First row nothing but 1, first row, plus the second column. So minus 1 is there in the second column, 2. Then take the square and ignore the row and column associating with that minus 1. That means that the first row, second column, if you ignore these two, what are the elements remaining? 1, 1, 1, minus 2. Take the determinant. 1 into minus 2. 1 into minus 2, how much? It is minus 2. Minus 1 into 1, it is 1. Am I correct? Therefore, it is minus 1. How much? 2 plus 1, 3. Then it is equal to minus 2 minus 1. This is equal to minus 1 power 3. What is the minus 1 power 3? Minus 1 into minus 1 into minus 1. 3 times. So, the minus, it is 1 cube. It is 1 cube actually. Minus 1 into minus 1 into minus 1. 1 into 1 into 1. And the symbols are minus sign is minus into minus into minus. If the minus are 3 times, minus into minus plus. Plus into minus minus, therefore it is minus. Then minus 2 and minus 1 is minus 3. Therefore here minus into minus plus, therefore 3. Therefore what is the cofactor of minus 1? 3. What is the cofactor of that minus 1 is 3. Okay, cofactor of minus 1 is 3. Similarly, find out what is the cofactor of this third element of the first row. Okay, likewise you can do all the things. You can do all the things. So what is the cofactor of 1? Similarly, cofactor of 1, cofactor of element 1 is equal to minus 1 whole power. How much? How we can write? It is first row, it is 1, third element, third column, it is equal to, ignore that, 1 into minus 3, it is minus 3 and minus 1. Therefore is equal to, it is 3 plus 1, 4. Minus 1, 4, it is plus 1. 1 into minus 3 minus 1, it is minus 4. Therefore minus answer is minus 4. So your cofactor is minus 4, right? So that is okay, 4. Similarly, what is the cofactor of this first element of the second row? Cofactor of this one means this particular one, that is minus 1 whole power. Okay, what is the row? Second row, first column. It is 2 plus 1 now. This 2 indicates second row, first column. Ignore that row and then column, then these are the elements. 1 into minus 2, minus 1 into minus 2, it is 2, and minus into minus plus, it will be 3. Directly I am writing because, so 2 plus 1, it is 3. If 3 is there, odd number, minus sign will come, it is minus 5. The answer is minus 5, ma. The answer is minus 5. Okay, it is minus 5. And similarly, cofactor of the second one, the middle one, it is minus 1 plus, what is this actually? The second row, second column, 2 plus 2. It is second row, second column, 2 plus 2. And ignore these two. Then 2 into 2 minus 4. It is 1 into 1 minus 1. This is equal to 2 plus 2, 4. So obviously it is plus sign, minus 5. So the cofactor is minus 5. Understood? The cofactor is minus 5. And similarly, what is the cofactor with respect to the third one? What is the cofactor with respect to third one? Find out. Very simple. What is there actually? Nothing to fear, nothing to feel any difficulty. Cofactor of element 1. Cofactor of element 1, I mean this one. What is the formula? It is minus 1 whole power second row. It is second row, third column, means 2 plus 3 into, take the, remove that particular, okay, ignore this row and column, then 2 into minus 3, 6, minus, all minus is there, plus 1. This is equal to 2 plus 3, it is 5, minus symbol will come, it is minus 6 plus 5, it is minus 5, is it not? Minus 5, it is plus 5 is the answer. So cofactor is 5. Plus 5. And coming to this particular element, cofactor of 1, cofactor of this particular 1 is equal to minus 1 whole power, minus 1 whole power. What is this actually? Third row, first column, 3 plus 1. Then ignore these row and column, these are the elements. It is 1 into minus 1 into 1, minus 1 and minus 1 is equal to 3 plus 1, nothing but the plus symbol will come here. It is, answer is minus 2. Minus 2. Cofactor of minus 3. Cofactor of minus 3 is equal to minus 1. It is third row and second column. Remove that element and then remove this. 2 into 1, 2. Okay. 1 into 1, minus 1. It is 3 plus 2, 5. I mean 3 plus 2 is 5, 1 power 5 is an odd number, it is minus symbol will come, and 2 into minus 1, 1, minus 1. Answer is minus 1. Cofactor is minus 1. And what is the cofactor of minus 2? Cofactor of minus 2 is equal to minus 1 whole power, I mean third row, third column, it is 3 plus 3. Ignore this row and column, it is 2 into 1, 2. Right? Minus symbol is there, plus 1 you will get. And it is 3 plus 3, 6. It is an even number, then your signal must be, the sign must be plus. 2 plus 1 is 3, plus 3. Then by taking all these values, so you have to write the cofactor. We already found that the cofactors of each element. So what is the cofactor of 2? What is the cofactor of minus 1? What is the cofactor of 1? What is the cofactor of 1? Like this, with respect to each element, put all the cofactors in that particular places. Okay, then what is that actually? The third is nothing but minus 2, minus 1 and then 3. Then if you put in order, now the cofactor matrix. So now the cofactor matrix we have to write like this. The cofactor matrix is denoted by, or is given by, the cofactor matrix is given by like this. You have to write the cofactors with respect to. What is the cofactor of 2 actually? It is 1, no? Cofactor of the second element is 3. Cofactor of this third element is minus 4. Following or not? Cofactor of first element is minus 5. Cofactor of the second, this element is also minus 5. Cofactor of this element is 5. And the cofactor of this particular element is, it is minus 2. Am I correct? And it is also minus 1. And the cofactor of the third one is, I think, 3. Am I correct? This is the cofactor matrix. This is called cofactor matrix. Cofactor matrix. Now take the transpose. If you take the transpose is nothing but, right, for this matrix you have to represent T upon like this in the power. If you write T, that is called as a transpose. Transpose. What is the transpose? What is the transpose of this? Nothing is there. All the rows will be converted into columns. That's it. So the transpose of this can be given as like this. Nothing wrong. All this 1, 3, 4 you can write like this. 1, 3, minus 4. This particular row element, this particular row you can write like this, first column. And the second row, okay, the second row, it is 1, 3, 4 you will write like this, 1, 3, 4. And then this particular minus 5, minus 5, you can write this is a 5. And the third row you can write like this, minus 2, minus 1 and 3. Okay, the first row will be considered as first column, the second will be taken as the second, the second row will be the second column, and the third row will be taken as the this is the transpose. This particular is called as the adjoint. This particular is called as the adjoint. Therefore this is therefore adjoint of A, adjoint of A is nothing but this particular 1, minus 1, minus 2, 3, minus 1, minus 1, minus 4, 5, 3. This is called as your adjoint matrix. Adjoint matrix. Then what is the inverse, my dear? What is the inverse? Inverse, what is the formula? What is the formula? So I can keep this one without erasing because I need this. This is what my adjoint A now. This is what my adjoint of A. I hope you are getting this. This is my adjoint matrix. Then what is the A inverse actually? A inverse is equal to what? Adjoint A by determinant of A, det A. Means that what? Adjoint A, you know, by determinant of A you have to do. That's it. By det A you have to do. What is det A? It is minus 5. We already obtained. By minus 5 nothing but what? All these elements must be divided by minus 5. Minus 5. You have to simply divide all these elements with minus 5. That is the meaning of it. Very simple now. What is there in this? Any difficulties there? No, not at all. Therefore, if you write all these things, then A inverse is equal to, it is minus 1 by 5. First element. Minus minus cancel 5 by 1, it is 1. And it is minus cancel 2 by 5. The third element is 2 by 5. Here minus 3 by 5. And the second is again 5 by 5, 1. And it is 1 by 5. And it is 4 by 5. And it is minus 1. Because 5 by 5, 1. It is minus 3 by 5. This is what your A inverse. This is what A inverse. I think it is quite enough if I can stop here. Then because I will finish here itself, because this is the A inverse. This is the inverse of a matrix. Then in subsequent presentation I will explain the further extension of this problem. That is how to solve this. That is, I think, x is equal to A inverse B there, no? That I will explain in the next presentation. I hope you understood well up to this particular point how to solve or how to find out the inverse of a given matrix. I hope you understood well, or if any clarification suggestion is required, you please comment in the okay, as your advice or whatever it is, then definitely I can address all those things, and the extension of this we'll see in the next presentations. Thank you very much.